Hello, welcome back. We're doing Chapter 4, Section 3, Writing Functions. I'm doing the guided practice problems. If you've been following the videos in order, then you know that. I'm on page 249 of the actual textbook. The PDF is on page 24. So the 249 is at the bottom. You can see it when you scroll through. But if you look at the little control bar across the top, it'll say PDF page 24. I'm going to do problems 7 and 8. So just like the last problem, we're going to identify the independent and dependent variables. But unlike that, we're going to take it one step further, where we're going to write a rule in function notation for each situation. So look at problem number 7. An air conditioning technician charges customers $75 per hour. There are two things that are being counted or measured in this situation. The first one is time, and specifically the time that the air conditioning technician is working. Okay, so the tech is doing some work on an air conditioner, HVAC, and that person is going to come back and present a bill and say, here's the number of hours that I've worked. In presenting the bill, that tech has calculated out how much the customer is going to owe, which is going to be the total cost. Now, we're keeping it simple for this problem. I know you're probably thinking this isn't simple, but in the real world, there's also going to be other fees that are going to be included. There's going to be tax, maybe there's going to be travel fees, maybe there's going to be some material fees. So these things do get more complicated. So just appreciate for the moment that this one, the tech is just charging $75 per hour. Which one's the independent variable? Which one's the dependent variable? So the decision about how much time the tech is going to work kind of depends on the job. If it's something easy, one time I had, Bonfi come out and look at our air conditioners, and I felt terrible because it was something I could have fixed. Just something got in the way of the fan blades. Ended up paying a lot of money for something I could have fixed. However, if it's a big, complicated job, especially for like a big building that has huge air conditioners on the roof, then it's probably going to take some more time. The total cost depends on how much time the tech is going to work. So this is the dependent variable, which makes this the independent variable. Now, I got to write this relationship in function notation. In order to do that, I have to find variables. I can certainly use x and y. We talked about how you can always use x and y if you want to describe that. However, it's sometimes when I got variables that, sometimes when I know what the variable stands for, like time and cost, I can use letters for that represent that. So I'm going to let t represent the time and c represent the total cost. I'm using that t and that c. Don't use t for total. Okay, if you're going to use t and t, that's going to be a bit confusing. After 1 hour, it's going to cost $75. After 2 hours, it's going to be 75 plus 75, which is 75 times 2. After 3 hours, it's going to be 75 times 3. So after t hours, it's going to be 75 times how many hours it is. And remember, I write that without an x and without a dot and without parentheses. I'll use parentheses if I evaluate later. All right? And that's going to give me the total cost. Now, you could also write this as a function. Function notation looks like this. F of t would be 75t. In which case, f would just be the name of the function. All right? Number 8, an ice rink charges $3.50 for skates and $1.25 per hour for you to go there. I don't think any ice rink that I've ever been to does that. You have to pay to rent skates, but usually you don't pay per hour. I don't know if there's like some sort of special deal or anything. You just pay to get in. But anyway, we'll use this as an example. You have something where they're keeping track of how many. There's lots of situations where you do rent things by the hour. So there's like an upfront fee, and then there's an hourly fee. So especially if you go to like any of the big box hardware stores that rent tools, they will have all their rental fees written out for you so you can figure that out. All right, there are two things that can measure here. All right, the time, and in this case, this is the time that you are spending skating. And one more time, no pun intended, we have the total cost, how much you're going to pay to go skate. This is the independent variable. So if you go to this ice rink, you get to decide how long you are going to skate. If you say, I'm only going to skate an hour, then they can tell you how much that's going to cost. If you say, I'm going to be here all day, I'm going to be here until you open, until you close, because I like to skate, then they will tell you that also, right? So how much it costs depends on how much time. So this is the dependent variable. And we can use, since we're also using time and cost, I'm going to use T and C one more time. But like I said, you can also use X and Y. All right, so for each hour, you're going to pay $1.25 to skate there. So 1 hour would be $1.25, 2 hours would be $1.25 plus another $1.25, just like we did up here. So that's $1.25 times the number of hours that you are going to skate. But unlike this problem, when we talk about additional costs, this one does have an additional cost. You have to add a one-time fee of $3.50 if you're going to rent skates. If you bring your own skates, you're good. Okay, but in this case, you're going to pay. This person is going to pay for skates, and that's going to give me my total cost. Just like last time, I could write it as a function. And it looks like that. Okay, so this is all for practice. These skills you're going to be seeing as we learn more about Algebra 1. So don't panic. This is a year-long situation. It'll be okay.